Is the ozone layer recovering? NASA announced on Thursday that the hole in the Earth's ozone is the smallest it's been for the last 29 years, though not because toxic emissions have gone down. The ozone hole that formed over Antarctica this year measured 7.6 million square miles at its maximum peak and is as small as it's been since 1988. Ozone molecules shield the Earth from the sun's UV radiation, but are being depleted by man-made chemicals like bromine and chlorine that are released into the atmosphere. The hole in the ozone has been growing larger over the years, measuring more than 11 million square miles at its highest. Ozone deteriorates more quickly in colder temperatures and in the presence of polar stratospheric clouds that encourage ozone-eating chemical reactions. This year's weak depletion is largely due to stormy conditions in the upper atmosphere, which warmed temperatures and kept toxic chemicals from destroying the ozone. While the small ozone hole resulted from mostly natural causes, steady improvements such as the banning of ozone-eating chemicals in a 1987 international treaty may have also contributed. Here's how we're trying to save the Earth.
Carbon turned to stone in climate change breakthrough. Researchers in Iceland are hailing a potential game changer for climate change after successfully converting carbon to rock. The project could help to reduce global warming by burying the waste CO2 produced by burning fossil fuels. Scientists at the Hultasheyri geothermal power plant in Iceland have converted carbon dioxide into the volcanic rock basalt. Researchers pumped 230 tons of CO2 into rock 500 meters underground, dissolving the gas in water to prevent it from escaping. More than 95% of the gas turned to stone within 2 years, speeding up a natural process that takes hundreds or thousands of years. A potential problem for the technique is that it requires 25 tons of water for every ton of buried CO2. However, researchers say seawater can be used, which is abundant at coastal sites. The project is seen as an improvement on existing carbon capture and storage methods that store CO2 as a gas, causing concern about potential leaks.
Cooling the planet at a cost. As temperatures on Earth reach unprecedented highs, extreme, potentially disastrous weather will become more likely. Scientists say there may be ways to intervene, but warn they come with risky consequences. Researchers are investigating strategies for geoengineering, one of which is mimicking the effects of a volcanic eruption. Erupting volcanoes spew out large amounts of sulfur-rich gases, which help cool the Earth by reflecting solar radiation back into space. The same effect could be recreated using planes that would inject sulfur into the atmosphere. But to cool the planet by 1 degree Celsius, 6,700 injections are needed eventually, which would cost $20 billion annually. This approach also risks destroying the ozone layer and reducing rainfall, enough to potentially cause droughts in certain regions. A similarly drastic approach to cooling the Earth can be achieved by thinning heat-trapping cirrus clouds. Seeding causes the clouds to break apart and lets more heat escape. The seeding process, however, must be precise, otherwise new cirrus clouds may form elsewhere and add to warming. But while sulfur injections and cirrus cloud seedings will cool the land, carbon dioxide levels in the atmosphere remain the same, and ocean acidification continues. As such, researchers argue the two strategies should be deployed more as a last resort, adding that reducing carbon emissions are much more effective at curing climate change. A carbon dioxide-sucking plant just opened in Zurich. The alarming rise in atmospheric carbon dioxide has led scientists to develop removal technologies to counter climate change. One such company in Switzerland has built a plant that directly removes this carbon dioxide from the atmosphere. The Climeworks plant is located on top of a waste recovery facility, which provides it with heat and electricity. Air containing carbon dioxide and other molecules are blown through several carbon dioxide collectors. The plant currently has 18 such collectors, which are large boxes fitted with filters that capture more than 2,400 kilograms of carbon dioxide each day. Carbon dioxide binds to the amines in the filter, while other molecules pass through and return to the atmosphere. Once saturated, the filter is heated to 100 degrees Celsius, causing the carbon dioxide to unbind and be extracted. The filtration system can be reused several thousand times, allowing this process of removal and collection to be a continuous cycle. The carbon dioxide collected by the plant can be stored underground, used to help make renewable fuels and materials, or supplied to the food and beverage industry. Climeworks provides 900 tons of carbon dioxide annually to a nearby greenhouse, which has reportedly increased their crop yield by 20%. Climeworks also hopes to remove 1% of global carbon dioxide emissions by 2025. Could geoengineering help save the planet? With global warming causing heat waves and rising sea levels, and potentially bringing about more devastating consequences, scientists are turning to climate engineering solutions to keep temperatures down. Geoengineering has two approaches to cool the planet: carbon dioxide removal and solar radiation management. Taking the direct air capture approach is Swiss company Climeworks, which uses several collectors to suck in air that contains carbon dioxide. The carbon dioxide is filtered and collected, while other air molecules are returned to the atmosphere. A separate Harvard project, meanwhile, is working on dimming sunlight. The team plans to release limestone particles using a high-altitude balloon and then observe its effect on the stratosphere. The limestone spray will supposedly reflect solar radiation and slow greenhouse gas warming. It will also neutralize the acids that destroy the ozone, thus helping to restore that protective layer. Another technique aims to cool the seas and prevent coral bleaching by spraying salt generated from saltwater to create more reflective clouds. Critics of geoengineering warn that such solutions are a temporary fix and run the risk of dealing more damage in the long run. It's definitely a radical step from reducing carbon emissions, which many believe is the more effective way to curb global warming. Eating beans over meat could save the planet. A new study shows Americans should probably eat more beans than meat if the country wants to meet its emissions target. Cows emit methane due to a digestive process known as enteric fermentation. Most of the methane is released through belching, and only a small percentage is produced through flatulence. The massive amount of greenhouse gas produced by cows is comparable to the pollution produced by cars. Growing pulses is greatly beneficial to the environment, as they are able to directly draw nitrogen from the atmosphere and convert it into nutrients. This means a reduction in the amount of fossil fuels used to produce nitrogen to create these nutrients. It is also much more water efficient to grow pulses than to raise cattle. Beans also provide similar nutrients to the human body as beef, without the increased risk of developing type 2 diabetes, stroke, and colorectal cancer. Research shows changing the population's diet from beef to beans could help the U.S. meet its emissions target by 2020. Another study published in April recommended substituting meat with crickets and mealworms in order to reduce greenhouse gas emissions. Would you give up your juicy steaks for beans and worms?